So I'm going to talk about how you can use Rust, not so much as a language, but its ecosystem, crates.io and Cargo, to shop for libraries that then you can wrap with Java or Python. So basically, this can be a whirlwind tour of a bunch of different techniques for using the FFI, or foreign function interface, to wrap Rust code that you can call from Java or Python. So in the Rust ecosystem, thanks to Go, when new languages ship, they have to have package repositories, otherwise they're not viable. So when Rust 1.0 shipped back in May 15th, 2015, it also came with crates.io, and that's the package repository. And now there's thousands and thousands of crates available. So then it's built-in tool for compiling Rust code, Cargo, can pull any one of those packages down from crates and compile it into your Rust programs. So, and then it can do so, since Rust is based on LLVM, you get all of the LLVM backend. So you get support for x86, ARM, and WASM. And then I'm going to show how to call it from Python and Java, but of course you can also call it from C or C++. The Rust folks like to talk about fearlessness in terms of concurrency or memory safety. So what Rust gives you, it's the speed of C++, but better safety than Java. It has no garbage collector, has predictable performance, and it's also data race free. There's lots of online resources. They can tell you the rest of the Rust story. There's 3 excellent books, which I recommend all of them. Another thing that Rust folks like to talk about is first it started with the Fire Flower, and then it morphed into Fire Mario. So what Steve Klabnik is trying to say is that Rust has a certain number of capabilities. Cargo, Rust up, all of its libraries, its ecosystems, but those capabilities turn programmers into Fire Marios. What can they go do with Rust? And so one thing we'll be talking about is how to take Rust code off of crates.io, wrap it a little bit, and be able to call it from Java or Python. So I purposely picked a fairly easy problem to solve. So the Levenstein distance, or edit distance, between 2 strings. There's lots of libraries on crates.io that you can select for this. So given 2 strings, return the number of edits to get from one string to the other. Maybe that could have been used for finding those drugs that were misspelled. First we're going to install Rust from Rust up. That's like a minute or 2 procedure. Override the tool chain into nightly, and then I like to install riprep and Tokai. They're 2 tools I use all the time. Riprep is a much faster grep. It actually powers finding files inside of Visual Studio Code. So if you use Visual Studio Code, you already have Rust code running on your machine. Next up is Cargo. So Cargo installs crates, it manages builds, it's easily extendable. People push updates or extensions to Cargo into crates itself, and then you can use Cargo to install those extensions. As my co-presenter Chris showed at the Rust meetup in January, there's a bunch of WASM tooling that you can install directly from Rust or from Cargo. Yeah. Cargo is the build tool that ships with Rust. Oh, here's a screenshot of searching for Levenstein on crates.io. We get an exact match, and then it gives you the exact string that you need to use to insert in your Cargo TOML file. So, the first thing we're going to do is wrap this library with a py03 lib, which allows you to marshal data efficiently back and forth between Rust code and Python code. So here's how we set up our environment. So we make a Python env, we activate it, we immediately upgrade pip, and then install setup tools, wheel, IPython, and Maturin. Maturin is the build tool that understands cargo TOML files and the PY03 library to build wheels for you. So we create a new library, cargo new --lib lev10, and then it makes this skeleton for us. It fills in the cargo TOML file and source librs. We can type cargo build and it will build straight out of the box. Basically a hello world application that we can go and extend. Now here's what the completed cargo TOML file looks like. I added the name, the crate type is a C dynamic library. The dependencies, that's what we copied from crates.io. And then PY03, set the version and then turn on the feature extension module. And then here's the code, the actual business logic so on the third line where it says Levenstein as levf. So we import that library that we set as a dependency. Now, lower down, we make a normal Rust function that wraps it. And then that function, and we do that just to make it more easily testable without having to go through the generated Pi module. So the Pi module up there is an extension that annotates that code so that the tooling knows how to expand that out and generate the scaffolding to then call from Python. So that generates the module down with the PyFN and Levenstein that exposes that function to Python through the C extension module. And then it automatically knows how to take the ampersand stir or borrowed string and pass it into Rust code. And then we can actually have a test in here as you would normally test a cargo module. So PY03 relies on nightly features. So there's two release chains for cargo or for the Rust compiler. One is stable and one is nightly. Nightly has features that are still in development, but nightly is also guaranteed to compile all existing Rust code that's out in the field. So we override the nightly compiler. We use Maturin to build our wheel, and then it actually in turn also builds the dynamic library. We just create this nice symbolic link, which then we can load directly from within IPython and load the lev10 module. And so you can just fire up IPython within the build folder after you've made that symbolic link, import lev10, and then you get lev10, Levenstein, and you can calculate the distance between those two strings. So the next one I'll show is how to call this same Rust module through Java using JNA or Java Native Access. Here's the dependency you would use in your POM file. Again, generate a skeleton. This time, basically this, you're gonna have the librs and then the Levenstein Java code, which simply loads that C library into Java. But the nice thing about both JNA and then the next one I'm gonna show is CFFI is that it doesn't require you to write any sort of custom code that's tied to your execution environment. It does handle some of the marshalling, like it makes it nicer to expose to C or C++ through that ABI. But unlike PY03, PY03 has symbols for your Python interpreter. So you have to have your Python interpreter set up for development. It needs to link into Python itself because that extension module knows about Python. The nice thing about the extension module knowing about Python is you can create Python dicts or Python lists directly from within your extension code. So if you have rich data structures you're trying to share back and forth, PY03 is probably the best bet. If you have more value types and more like sort of native just ints and strings, JNA or CFFI are a much lower friction way to get calling into native code. So here's the cargo TOML file for this. As you can see, there's nothing specific about Java in here. It's just generating a shared library. This one I used a different Levenstein library, StirSim. It has a lot more metric functions built in, but we're still just going to use the normal one. And then in here, here's the Rust code. We do need to do some things that are unsafe because we're taking in, since we're operating at the C ABI. We're just getting const char pointers into strings. We're not using a rich string type like we would use in Rust that's, bounds checks and what have you. So the first thing we do is this toString helper function takes in a C string and emits a Rust owned string. So it says, if the input is null, just bail, convert this C string from a pointer and assign it to C_stir. Then we take that C stir, we convert it into a slice, and then we unwrap it. That can fail. If that fails, it will just panic and you'll get a stack trace. And then the last line, the rstir toString, that actually converts that slice into an owned string, and that thing then moves out of that function. So this allocates, but that string moves out of that function. And so we use that in this Levenstein function that we expose, and this is how you would expose something to C or C++ if you want to make a dynamic library. So it takes in const chars and then returns the edit distance between them. So it converts those const chars into owned strings and then takes a reference to them, making a slice. And then returns the result. Since it's the last thing with no semicolon in the end, there's an implicit return for the last statement to execute in Rust. And then in the Java code, we import GNA library and native. This is all just sort of the boilerplate, but as you can see, you really only have to annotate the function saying it takes two strings and returns an int. And then it will automatically load the lev3.so that is within your search space, and then present you back with an instance of this library that you can then call into. So the cool part about crates.io and Cargo is that there's thousands of libraries that you can go search for. They're relatively easy to wrap. You don't have to know a lot of Rust to do it, and that if you do anything wrong, the compiler will tell you. In this one example, there was a small amount of unsafe code, but if you ever program in C or C++, it's basically just trying to marshal C data types into something that Rust can understand. And then it's also unsafe code. So any code that could cause a seg fault or some other unsafe exit condition from an application. So if you have that code, it has to be marked with unsafe. So you can also easily look at all the libraries that you can consume and see if they use any unsafe code. If they don't, then you're guaranteed to be memory safe and data race safe for the code you write, which is really important if you're embedding some extension code within your Java runtime or your Python runtime, and you're unsure about how much damage it could do. By not using any unsafe code, you're guaranteed to not do any damage and continue to get clean stack traces when things crash. So what I didn't talk about in this is how to actually deploy those artifacts as part of your data flow job. That's a follow-on talk on how to actually get those native artifacts, both built for the deployment container that's running, as well as get it into the job itself. Another exciting thing that's upcoming, which we talked about at the Rust meetup, a month and a half ago, is WebAssembly, which is a portable bytecode for native code on the web, but can run within WASM environments. Again, Rust helps out there because there's a tool called WASMtime, which has its own JIT engine, which can run WebAssembly. And it's not, there's some features that are coming up like WebIDL or interface definition language, which makes calling between Rust code and WASM code a lot cleaner, but that's still in development. But I think in the next 3 to 6 months, the same exact thing where I'm wrapping native code and shipping it off as part of the Beam job, we can then ship WebAssembly code as part of the job and then have that run. So we could make architecture and platform agnostic sort of native extensions that run at close to the speed of C or C++, and that's just around the corner. So I've pushed all of the examples There's 3 of them. The other one is the CFFI code. It looks just like the JNA code, but it's Python that's calling into native libraries. And if you have any questions about it, feel free to submit an issue or drop me an email. I know that was a lot to take, and there was way more code on that than I wanted to have, but I don't think there was really a way around that. Yes. It's multi-paradigm. So, oh yeah, the question is Rust a functional programming language? It's not really a functional programming language, but it tracks the ownership of all pieces of memory. So if you're the only owner of it, you can mutate it. So one of the sort of the examples of functional programming is that you have no side effects, or you have uncontrolled mutation. So it's on the spectrum. You can do functional-ish programming in Rust. Mm-hmm.
They are very sweet. They don't have race conditions because they don't have state variables.
Mm-hmm.
Because everything is function, and they compute the functional state every time the function gets input.
Correct.
That is intensive on memory, but it's data race free. So when you mentioned that Rust was data race free, I assumed it wasn't storing on that stage at any point, which is why I thought it was pure.
It's data race free because it tracks the ownership of all objects that are alive. So it can guarantee that there's not 2 points in your code where you're trying to mutate something at the same time. Yes.
Is there a disadvantage to using stable code versus the nightly code?
The question was, is there a disadvantage to using nightly versus stable? There is a possibility that your nightly code could break in the future when the nightly compiler changes. So it is not as stable code, but for the most part, things that have been running in nightly, it really depends on the feature you're depending on in the nightly compiler.
For transformation purposes.
Yeah, for transformation purposes, like the output of the nightly compiler is just as good as the stable compiler. One of the nice things about having crates.io and having so much public code out there is every time a new release of the Rust compiler goes out, they do a thing called a crater run, where they actually compile every piece of known code out in the world and see if the compiler breaks. So that's one of the tests they do.
So one question, like, do we still do it marginally? Or like, how much is the overhead for marginal data?
The question,
transfer them.
Right. So the question is, how much marshalling overhead is there? It depends on it depends on the FFI layer, or like what it's doing. For strings, in both of these cases, they're actually getting copied when they go into Rust. There is a possibility of allocating them in place, but that takes a little bit more work. But for the most part, value types make it through. If you're needing to move a lot of data, then you would go to extra work to make sure that you're basically making a view over the data rather than copying it down into Rust. The nice thing about it is, though, Rust really gives you affordances for doing that in ways that would be difficult. Yes.
Is that a public repo?
I believe I just set it to public. Yeah. I'll check after this. Yes. I'm probably not skilled enough to make a Rust SDK, but I think it would be super, super awesome.